Crop rotation has been a cornerstone of agricultural practices for centuries, and its significance has only grown as we face the challenges of modern farming. In this video, we will explore why crop rotation works and delve into the science behind this age-old technique. By understanding the mechanisms at play, farmers can enhance soil health, improve crop yields, and contribute to sustainable agriculture. To begin, let's define what crop rotation is. At its core, crop rotation involves alternating the types of crops grown in a particular field over a sequence of seasons. Instead of planting the same crop in the same place year after year, farmers strategically change the crops they cultivate. This method is not just a random choice, it is a well-thought-out practice based on scientific principles that maximize the health of the soil and the productivity of the land. One of the primary reasons crop rotation works lies in its ability to disrupt pest and disease cycles. Many pests and diseases are crop-specific, meaning they thrive on particular plants. By rotating crops, farmers can break the life cycles of these pests and diseases, reducing their populations and minimizing the risk of infestations. For example, if a farmer plants corn one year, the pests that target corn will have a food source. However, if the following year, that same field is planted with soybeans, those pests will find themselves without a suitable host, thereby reducing their numbers significantly. This natural disruption leads to healthier crops and less reliance on chemical pesticides, promoting a more sustainable farming approach. In addition to pest management, crop rotation enhances soil health. Different crops have varying nutrient requirements and root structures, which means they interact with the soil in unique ways. For instance, deep-rooted plants such as alfalfa can access nutrients and water from deeper soil layers, bringing them to the surface when they die and decompose. Conversely, shallow-rooted plants like lettuce may not reach those deeper nutrients, but can thrive in the top layers of soil. By rotating these types of crops, farmers ensure that the soil remains balanced in nutrients and that no single nutrient is depleted over time. This practice also encourages a diverse microbial community in the soil, which is essential for nutrient cycling and overall soil health. Another scientific principle at play in crop rotation is nitrogen fixation. Certain crops, particularly legumes like peas and beans, have a unique relationship with nitrogen-fixing bacteria. These bacteria live in the root nodules of leguminous plants and convert atmospheric nitrogen into a form that plants can use. When legumes are rotated with other crops, the nitrogen they fix enriches the soil, providing a natural fertilizer for subsequent plants. This not only reduces the need for synthetic fertilizers, but also fosters a more resilient ecosystem. Furthermore, crop rotation can improve soil structure and prevent erosion. Different crops have varying root systems that contribute to the formation of soil aggregates, which are essential for maintaining soil structure. Healthy soil aggregates improve water infiltration, reduce runoff, and enhance the soil's ability to retain moisture. When farmers rotate crops, they are effectively promoting a more robust soil structure that can withstand the forces of nature, such as heavy rains or wind. The timing of crop rotation is also crucial. Farmers often plan their rotations based on the seasons and the specific needs of the crops. For instance, planting cover crops during the off-season can prevent soil erosion, suppress weeds, and improve soil fertility. Cover crops, such as clover or rye, are planted after the main harvest and can be tilled back into the soil before planting the next crop. This practice not only adds organic matter to the soil, but also helps to fix nitrogen and improve overall soil health. In addition to the agronomic benefits, crop rotation can have economic advantages for farmers. By diversifying the types of crops grown, farmers can reduce their financial risk. If one crop fails due to disease or market fluctuations, having a rotation plan in place means that farmers can rely on other crops for income. This diversification can also lead to increased market opportunities, as farmers can produce a variety of products to meet consumer demand. Now, let's take a closer look at some specific examples of successful crop rotation practices. One classic example is the three-field system, which dates back to medieval Europe. In this system, farmers divided their land into three sections. In one section, they would plant a winter crop, such as wheat. In the second, a spring crop, like barley. And the third section would remain fallow. This system allowed the soil to recover, reduced pest populations, and ensured that farmers had a steady supply of food throughout the year. Another modern example is the use of cover crops in conjunction with cash crops. Farmers might plant a cover crop, such as vetch or rye, after harvesting their primary crop. The cover crop grows during the off-season, protecting the soil from erosion and improving its fertility. When the time comes to plant the next cash crop, the cover crop can be terminated, and its biomass can be incorporated into the soil, enriching it for the next planting. As we consider the future of agriculture, the importance of crop rotation becomes increasingly clear. With the pressures of climate change, soil degradation, and the need for sustainable practices, farmers must adopt methods that not only increase productivity, but also protect the environment. Crop rotation is a powerful tool in this regard, offering a holistic approach to farming that benefits both the land and the farmer. In conclusion, crop rotation works because it is rooted in scientific principles that enhance soil health, manage pests and diseases, and promote biodiversity. By understanding and implementing these practices, farmers can create a more sustainable agricultural system that meets the needs of today while preserving resources for future generations. As we continue to explore the science behind crop rotation, it becomes evident that this practice is not just a relic of the past, but a vital component of modern agriculture. Embracing crop rotation is not only an investment in the soil, but also an investment in the future of our food systems. Thank you for joining us in this exploration of why crop rotation works. We hope you found this information enlightening and inspiring. Don't forget to like, subscribe, and share your thoughts in the comments below. Let's continue the conversation about sustainable farming practices and the science that supports them.